Good afternoon, everyone. Today, I will tackle about superstructure. What is superstructure? Superstructure is the part of building which is above the ground and which serves the purpose of building's intended use. In the figure shown, the portion of the structure that is above ground level that receives the live load is referred to as superstructure. The superstructure of a building is the part that is entirely above its foundation or basement. It includes plinth, wall and columns, beams, arches, roofs and slabs, lintel, parapets, and stairs. In this lesson, we will be able to know about stonework, brickworks, blackworks, cavity walls, and opening in walls. The first topic is stoneworks. We will be focusing about the ashlar walling and the rubble walling. Stonework. The natural formation of stones or rocks is a very long process, which commenced when the earth was composed only of gases. These gases eventually began to liquefy, forming the land and the sea, the land being only a thin crust or mantle to the still molten core. Rock, that is removed from its natural site and generally cut or dressed and then finished for building purposes, is called stone. The art of building the structure with stones as constructional units is called stonework. The two main types of stoneworks are the rubble walling and the ashlar walling. In ashlar walling, this form of stone walling is composed of carefully worked stones, regularly coursed, bounded, and set with thin or rusticated joints and is used for the majority of high-class facing work in stones. The blocks may be either square or rectangular. The stones which are used in the category are accurately dressed. The masonry has very fine joints of the order of 3 mm thick. It is the highest grade of masonry work and is very costly. These are the typical ashlar walling: ashlar fine-tooled, ashlar rough-tooled, ashlar rock rustic or quarry-faced, ashlar chamfered, ashlar black in coarse, and ashlar facing. In rubble walling, these are walls consisting of stones that are left in a rough or uneven state, thus presenting a natural appearance to the face of the wall. These stones are usually laid with a wide joint and are frequently used in many rural areas. The stones which are used in this category are either rough or undressed. The masonry has wider joints since stones of irregular sizes are used. These are the typical rubble walls. The first one is the uncoarse random rubble wall. It is the cheapest, roughest, and poorest form of stone. The second one is the coarse random rubble wall. It is a type of masonry which is commonly used in the construction of low-height walls of public buildings or residential buildings. The third one is the coarse square rubble wall. This type of masonry is made up of hammer-squared stones. And the last one is the flint stone wall. This type of masonry is used in the areas where the flint is available in plenty. The general requirements of stoneworks are: it should be hard, tough, and durable. It should be perfectly dressed. The mortar to be used should be good quality. As far as possible, broken stones or small stones chips should not be used. Joints must be maintained of uniform thickness to its minimum norm, and proper bands should be maintained throughout for alternate courses. And the large, flat stones should be used below the seat of girders. Trusses for distribution of point loads on wider area of walls. The third topic is brickworks. We will be able to define brickworks, types of bonds, and the construction procedures of different types of bonds. In the history of the art of brickmaking and the craft of bricklaying can be traced to before 6000 BC. It started in Western Asia, spread eastwards, and was introduced by the Romans. The use of brickwork flourished during the 3rd and 4th centuries, after which the craft suffered a rapid decline until its reintroduction from Flanders towards the end of the 14th century. Since then, it has been firmly established and remains as one of the major building materials. The basic raw materials is shale, clay, or brick earth, all of which are in plentiful supply in this country. The raw material is dug and then prepared either by weathering or by grinding before mixing with water to the right plastic condition. It is then formed into the required brick shape before being dried and fired in a kiln. The standard size of a bricks is 215 mm by 65 mm by 102.5 mm. Let us learn about different dimensions of a brick. The stretcher face and the header face. The stretcher is a brick laid with its length horizontal and parallel with the face of the wall or other masonry member. The header is a brick laid so that only its edge shows on the face of the wall. Bricks are a diverse product. Therefore, they are difficult to standardize for classification according to its varieties, qualities, types, place of origin, raw materials, use, color, and surface texture. Now, let us discuss about the process of cement mortar for bricks. It must have adequate strength but not greater than that required for the design strength. It must have a good workability. It must retain plasticity long enough for the bricks to be laid. It must be durable over a long period. It must bond well to the bricks. It must be able to be produced at an economic cost. The preparation of cement mortar is done in the ratio of 1:3 for grade M 7.5 cement. That is 1 bag of cement with 3 bags of sand and water whose ratio is 70% weight of cement. Brickwork bonding. Bond is the arrangement of bricks in each course so as to ensure the greatest possible interlocking and to avoid the continuity of vertical joints in two successive courses, both on the face. The various types of bonds generally used are the stretcher bond, header bond, English bond, and Flemish bond. In stretcher bonds, all the bricks are arranged in the stretcher courses. In header bond, all the bricks are arranged in the header courses. In English bond, consists of headers and stretchers courses. And lastly, the Flemish bond, each course comprises of an alternate header and stretcher. The third topic is blockworks. We will discuss about the clay blocks and the precast concrete blocks. In clay blocks, they are manufactured hollow by an extrusion process and are fired as for clay bricks. The first one is standard block. Standard block has been used for the inner skin of cavity walls, but has now been superseded by developments in lightweight concrete blocks. The second one is the partition blocks that is intended primarily for partitions. The principal ingredients of precast concrete blocks are cement, sand, aggregates, and water. It is produced in a variety of shapes and sizes using manual or machine construction techniques. These are the kinds of precast concrete blocks: the keyed surface block, solid block, hollow block, and cellular blocks. The main advantages of blockwork are labor saving, easier fixings, higher thermal insulation properties, lower density, provides a suitable key for plaster and cement rendering. The disadvantages are lower strength, less resistance to rain penetration, less load-bearing properties, and lower sound insulation properties. The fourth topic is about the cavity walls. We will discuss the definition of cavity walls, the building regulations, and the advantages and disadvantages. What is cavity wall? A cavity wall is a double wall consisting of two separate walls called skins or leaves of masonry separated by an air space and joined together by metal ties at suitable intervals. These walls are generally exterior walls, although sometimes used as interior walls due to a good sound. According to the building regulations, the compressive strengths of bricks and blocks should be not less than 5 Newton per square millimeter and 2.8 Newton per square millimeter respectively for buildings up to 2 stories. Cavities, gap between masonry faces, should be at least 50 mm but may be up to 300 mm. Wall ties should comply with the specification for ancillary components for masonry. Cavity walls normally have leaves at least 90 mm thick. The combined thickness of the two leaves of a cavity wall should be not less than 190 mm for a maximum wall height of 3.5 meters, and length not exceeding 12 meters, and also for heights between 3.5 meters and 9 meters in wall lengths not exceeding 9 meters. Wall lengths and heights up to 12 meters require a minimum thickness of 290 millimeters. Mortar should be given for mortar designation. Cavity walls of any length need to be provided with roof lateral supports. There are some advantages of cavity wall construction. Able to withstand a driving rain in all situations from penetrating to the inner wall surface. Gives good thermal insulation, keeping the building warm in winter and cool in summer. No need for external rendering. Enables the use of cheaper and alternative materials for the inner construction. A nominal 255 mm cavity wall has a higher sound insulation value than a standard 1 brick thick wall. It can accommodate supplementary insulation material. The disadvantages of cavity wall construction are: it requires a high standard of design and workmanship to produce a soundly constructed wall. This will require good supervision during construction. The need to include a vertical damp-proof course to all openings, and slightly dearer in cost than a standard 1 brick thick wall. The last topic is the opening in walls. We will be able to know the components of a wall openings. Openings have to be included in walls to provide ventilation, sunlight, and aesthetics. From the construction point of view, the key issue is the detailing around openings. This must ensure that no moisture or damp can penetrate and must protect against the creation of cold bridges. Heads and lintels. The head is a part of the opening such as a door or window that has the task of supporting the load of brickwork above it, as well as carrying the load. The head has to transmit the load to the jambs at the sides. Lintels or beams are used for the construction of such heads. These can be made from different materials depending upon the load being supported. If a lintel is not used the weight of the brickwork above, it will cause collapse and cracking of the brickwork and building. These are the types of lintels, the exposed lintels and concealed lintels. Jambs. This is the vertical part of the wall opening on a single door or window opening. One side is known as the hanging jamb and the other is the closing or shutting jamb. There are several different types of jamb treatment depending on the type of wall on a solid wall. The jambs are banded to give them the shape and strength. In cavity walls, the area where the opening is to be closed by a timber frame incorporating a damp-proof course. Building regulations require that the detailing of vertical DPC, cavity closure, and insulation is particularly important. If this is not done correctly, cold bridges could be created and moisture or damp could be penetrate. This figure is a typical jump treatments to openings. Seals and thresholds. Look at any window or door that you will see that it has a piece of material below it, plastic, concrete, or timber. This material is shaped to allow rainwater to run off away from the opening. This is called a seal or threshold. It does not have to carry any load, but it is simply there to get rid of the rainwater that runs down the surface of the door or a window. This is the typical seal treatments to opening. That's all. Thank you.